So here we have once again fractions, exercise 3b, in which number 1 states that you find whether the fractions 5 by 8 and 7 by 8 are like or unlike fractions. So you can observe over here that these both fractions have equal denominators. So when the denominators are same, we say that the fractions are like fractions. But in case when I find fractions like 8 by 15 and 8 by 21, these fractions have different denominators. The denominators are unequal. Therefore, we say that they are unlike fractions. Okay. So later on, if you want to change these unlike fractions into like fractions, you have to make their denominators same or denominators equal, isn't it? Referring to question number 2, we have convert fractions to equal denominators, means they have given you 5 by 6 and 7 by 9, and they have asked you to change to equal denominators. Now, in order to change equal denominators, naturally you have to take out their LCM. We had done this in our previous session, 6 and 9. So 3 2 times and 3 3 times. So we get, have a look that their LCM is 3 into 2 into 3. This is the LCM, okay? And the LCM equals to 18. Now, in order to make these two fractions having equal denominators, means their denominator should be equal to their LCM. Denominator should be equal to LCM. Therefore, let's see. When in fraction 5 by 6, what we need to do is remove 6 from here. So 3 2s are 6. If I remove 6 from here, 3 remains. So I will multiply the denominator by 3 and the same numerator by 3 also. So we have 15 by 18. Here, similarly 7 by 12, 7 by 9, and in 7 by 9, remove 9 from here. 3 3s are 9. You have 2 over here. Multiply the numerator also by 2 and you get 14 by 18. So I find that both of the fractions have equal denominators. Okay, I'll pick up one bigger number like 4 by 3, bigger number. So let us come to a bigger number. Okay, 4 by 5, 17 by 20, 23 by 40 and 11 by 16. So here the same thing, I have to make them, or I have to convert them with equal denominator. Okay, equal denominator. In order to convert into equal denominator, the denominator should be equal to LCM. This is the rule, general rule. So what we are going to do is we are going to find out their LCM, least common multiple of 5, 20, 40 and 16. Okay, so let's divide with 5. 5 1 times, 4, 8, 16. Then we have 2 over here. 2, 4, 8. Then again 2. 1 times 2, 4, 1, 2. So I find that the LCM is equal to 5 times 2 times 2 times 2 times 2, isn't it? 5 times 2 times 2 times 2 times 2 is equal to 80. Now, in order to convert each of these denominators, like 4 by 5, when you have 4 by 5 and you want to convert the denominator to 80, what we need to do is we are going to remove 5 from here. So let's remove 5 from here. So once we remove 5 from here, we get 2 2s are 4, 2s are 8, 2s are 16. So we'll multiply both the numerator and the denominator by 16 and we get 64 by 80. Similarly, in 17 by 20, the same thing. Let's remove 20 from here. 2 2s are 4, 5 2s are 10, 2s are 20. So I have removed over here. So what remains? 2 2s are 4. So I am going to multiply both of them by 4. So I'll get here as 68 by 80. Similarly, 23 by 40. And if I remove 40 from here, let's remove 40. 5 2s are 10, 2s are 20, 2s are 40, only 2 remains. So 2, I will multiply it by 2 in the numerator and the denominator also, and we'll get 46 by 80. Similarly, 11 by 16. In 11 by 16, what do I find? Let's remove 16 from here, okay? So 2 2s are 4, 2s are 8, 2s are 16. When I remove 16, I get 5. So I am going to multiply with 5 in the numerator and the denominator to get 55 by 80. So what do we see? That these fractions have got converted to equal denominators, and after you have converted to equal denominators, you can easily find which fraction is greater, okay? Or you can arrange the fraction, okay, in ascending or in descending order, isn't it? Now let's come to another sum, that is number 3, and here we have change fraction with equal, the same thing, reverse, isn't it? Reverse, we are talking about reverse, REVERSE, reverse. So in reverse, you have to change into equal numerator, change fraction into equal numerator. So here also we will find the LCM of numerator. So in number 1, which is already given as 6 by 13, 15 by 23 and 12 by 17, you are being asked to convert each of the numerator to an equal value. So we will find the LCM of numerator, that is 6, 15 and 12. So what we get? 3 2 times, 5 times, 4 times, 2 1 times, 5 remains, and 2 2 times. So here the LCM is equal to 3 into 2 into 5 into 2, isn't it? Is equal to 60. Now what I am going to do? I am going to convert each of the numerator to 60. So let's remove, in 6 by 13, let's remove 6 from here. 6 from here. So if I remove 6, I get 5 2s are 10. So I am going to multiply both the numerator and the denominator by 10. So you can see here you have 60 by 130. Similarly, you have 15 by 23, isn't it? 15 by 23. So in 15 by 23, if I remove 15 from here, 5 3s are 15. What remains? 2 2s are 4. So I'll multiply both the numerator and the denominator by 4, and I'll get 15 4 times 60 by 92. Yes. And then of course 12 by 17. In 12 by 17 I would use a black pen. 12 by 17. Let's remove 12 from here. 3 2s are 6 2s are 12. 5 remains. So I am going to multiply the numerator and the denominator by 5, and I'll get 60 by 85 as our final solutions, and I find that all of these fractions have got converted to equal numerators. Okay, let us pick up one more number, a bigger number, okay, so that it easily gets into your head. We are doing the same thing, that is change to equal numerator. So there is nothing different over here. In number 3 we have 15 by 19, 25 by 28, 9 by 11 and 9 by 11 and 45 by 47. Do the same thing as I said. Find out the LCM. LCM of what? LCM of the numerator, because we are here to make the numerator equal, isn't it? 15, 25, 9, 45, and what do I find? That their LCM is, okay, 3 1 times 5, and finally I get here as 3 1 and 1. Okay, 3 1 and 1. Yes, so I have the LCM as 5 into 3 into 3 into 5 is equal to 225. So each of the numerator will be equal to 225. How? And we are not going to divide, we are not going to make our task complicated. Like 15 by 19. Remove 15 from here. 5 3s are 15. So 15 remains, and you are going to multiply the numerator and the denominator by 15. So you will get 225 by 285. Similarly, in 25 by 28, I find that if I remove 25 from here, 5 5s are 25, 3 3s are 9 remains. So I will multiply by 9, and I will get 225 by 252. Similarly, in 9 by 11, if I remove 9 from here, 3 3s are 9, so 25 remains. So I will multiply by 25 in the numerator and the denominator, and ultimately get 225 by 275. Similarly, in 45 by 47, if I remove 45 from here, 5 3s are 15, 15 3s are 45, 5 remains. I will multiply by 5 in the numerator and the denominator, and finally reach a value 225 by 235. So here you can see that I have converted all of these fractions to equal numerators, and again here you can compare the fractions, that which fraction is bigger or which fraction is smaller when we come to question number 4, isn't it? In question number 4. What do we observe, or what are we asked? We are asked put the fraction in ascending order. Ascending order. So in ascending order, what we need to do? The same thing. Make their LCM equal. Make their denominator equal to LCM. So first we need to find out the LCM of 5 by 6, LCM of 6, 8, 12 and 10, isn't it? So let us find out the LCM, and here we go. 6, 8, 12 and 10. 3 2 times 6, 8, 4, 10. 2 1 times 4, 2, 5. 2 2 1 times 5. So we get 3 into 2 into 2 into 2 into 5 is equal to how much? 120 is our value. So each of these should be equal to 120. So 5 by 6, remove 6 from here and you will get 2 2s are 4, 4 5s are 20. So I will multiply with 20 in the denominator and the numerator in order to get a value 100 by 120. Similarly, in 7 by 8, we will do the same thing, and we are going to multiply. Let's remove 2 2s are 4, 2s are 8, so 5 3s are 15 remains. So I will multiply by 15 and finally get what I am going to get. 15 into 8 into 15 is equal to 120, and this is 105. Similarly, 11 by 12, isn't it? If I multiply this by 10 and 10, I'll get 110 by 120. And one more number is there, 3 by 10, isn't it? 3 by 10. So in 3 by 10, if I multiply, let's remove 3 from here, isn't it? If I remove 10, 5 2s are 10 from here, so 3 2s are 6, 2s are 12. So I am going to multiply the numerator and denominator by 12 and I'll get 36 by 120. So what do I find? I find that all of them have equal denominators, therefore equal denominator, you can see over here, therefore you can easily judge which is bigger and which is smaller. How you can judge? Let's see. I find that first is, for the smallest is 3 by 10. 3 by 10, where is 3 by 10? 3 by 10. Yes, 3 by 10. And then 7 by 8, 5 by 6 and 11 by 12 is the value which are in ascending order. You can see 36 first, and then 7 by 8, 105, then 100, and then first is 36, then you have 5 by 6, that is 5 by 6, this is 5 by, here it should be 5 by 6, 5 by 6, then the bigger number over here is 7 by 8, and then the biggest is 11 by 12, yes, now it's correct. Okay, now before I end up, I would remind you that we had made a small mistake, in our previous session, which was that when you divide any number, isn't it, by a divisor, dividend by a divisor, naturally you will get 7 5s are 35, and here you get a remainder as 3, Okay, so this is your quotient, while this is your remainder, and this is your divisor, this is your dividend. So the format in writing mixed value, mixed number, should be equal to quotient remainder by divisor, isn't it? Quotient remainder by divisor. Or you can say that the same value 38 by 7, 38 by 7, 38 divided by 7 can be written as 38 divided by 7 can be written as quotient was 5, okay, remainder was 3, and then divisor was 7, because remainder will always be less than the divisor. Remainder will always be less than the divisor when you divide a number. Okay, let's end up here. Thank you.